Thanks, everybody. Appreciate you being here. It's very nice. I'm very happy to be back in New Zealand again. So yeah, I'm Tyler McMullen, and I want to talk to you about why I think that serverless and WebAssembly were actually two technologies that are actually kind of made for each other. And the spoiler for this, I'll just tell you the ending, is that they are because we did that on purpose. Yes, so if you don't know who I am, that is exceedingly reasonable. I'm the co-founder of Fastly. If you don't know Fastly, that's slightly less reasonable, but I understand. We are one of the world's first edge clouds. We've been around for about 13 years now, and that kind of entails CDN services, edge security services, as well as edge serverless, right? Which essentially just means running your code, your functions, all over the world extremely fast. That's the idea. My job at Fastly for the last 13 years has been as the CTO, growing us from a handful of engineers up to hundreds of engineers and thousands of employees. But part of that job was helping to design how exactly we built this edge serverless platform that I'm going to describe. However, last month, I made the choice that I would desperately like to get back to doing the thing that I was actually good at that got me here, which was writing code, which I don't know if you know this. If you're a CTO of a 1,200 person company, you do not write code anymore. That's not a thing. That's just straight up, that's a terrible idea. So I actually stepped down as CTO last month, which is very exciting for me. And right now I am actually on vacation. So it is very nice to be able to take a minute to breathe again. The reason I'm telling you all this is to kind of explain the perspective I'm coming at this from. I'm not really going to talk much about Fastly here because I'm on sabbatical. Like, what am I doing? But rather, I'm going to talk about the ecosystem and especially about WebAssembly. However, at the end, I will come back around to Fastly a little bit to talk a little bit about how or why I think the things that make WebAssembly really good for serverless are, I think, especially important for an edge serverless environment like Fastly. Right? So I'm here mostly to talk about WebAssembly. How many people here have played with WebAssembly? Or let's start with who knows what WebAssembly is? Okay, a decent chunk. How many people have actually tried or played with WebAssembly? Yeah. Okay. Yikes. We have some work to do. And how many people would say they understand WebAssembly? One. Hell yeah. Wait, two. 2.5. Okay, cool. Great. So then this part will not fall on deaf ears. WebAssembly is actually, I would argue, quite simple for some versions of the word simple. A WebAssembly module is composed of some code, which is compiled from whatever language you started with. It specifies the functions that it imports. It specifies the functions that it exports, and there is some memory associated with it. And that is all. That is in the entirety of a WebAssembly module. So you can go a step further and say, this is the entire abstract syntax of WebAssembly, of the assembly language itself, right? That is shockingly small, for what it's worth, for those who are used to looking at abstract syntax things. That's the entire thing. You can go a step further than that and say, this is the entire semantics of WebAssembly, which again, I'm not expecting that most people would look at this and understand it. What I am going to say is that this is all of the information that you technically need in order to write a WebAssembly interpreter or compiler. You could do it entirely based on the information that is currently on the screen. That is a thing that one can do. You shouldn't, but you could. You could do it for fun. It'd be fun. The point is that as far as languages go, WebAssembly is actually very simple at its core, right? Right, a number of years ago, sometime after WebAssembly had been created and deployed into browsers, right around that same time actually, a small group of us who were involved in those days got together because we had a realization around the same time. The realization was that Wasm had, while it had great potential for the browser, it actually had I would argue some possibly even more important potential outside of the browser, right? So we founded this nonprofit, which is called the Bytecode Alliance. It was Fastly and I believe at the time it was Red Hat, there was Mozilla, and man, I should really remember who their founders were. That's a problem. Anyway, so it's now, however, about 30, 35 companies that work together on this. So we founded this nonprofit, and we work together to build and maintain the tools that you need in order to use WebAssembly outside of the browser, right? And so like, companies like Microsoft are part of that at this point. Google is also a part of it. There's a bunch of us, right? So one of the main things that we work on together is something called the WebAssembly component model. Okay. A component is the next abstraction level above a WebAssembly module, which I just described. That is just the code, functions in, functions out memory, right? That's a module. A component wraps that, right? Okay? So why? Why is that a thing? WebAssembly is, again, designed to be highly portable. It'll run on damn near anything at this point. You can run it on any kind of processor you can throw at it. But portability is kind of a tricky word in that, like, yeah, the instructions can run on anything. But like, interacting with a WebAssembly module is kind of like attempting to make a syscall in assembly code, right? Like, you can do it. It's not exactly intuitive. Like, that's exiting. That's exiting a program, for what it's worth, yeah. So the idea with the WebAssembly component model is how can we improve the way that WebAssembly interacts with the outside world? Okay, so going back to this for a second, one of the downsides of being so crisp and simple and efficient is that the higher level concepts are sometimes left unspecified, right? And that's like kind of intentional, right? So in the case of WebAssembly, zoom in here, this is the entire set of types that are available inside of a WebAssembly program, like after it's compiled. You can see here we have some numbers and some other numbers, and that's it, right? So, right. So essentially it's just numbers, right? So WebAssembly has no concept of things like strings or anything like that. And so, right, like, which means in this diagram when we talk about import and export functions, what we're really talking about are functions that might take a number and return a number. And if I want to say take a string and return an error type, that is not a thing. You cannot do that thing. Instead, it's left up to individual languages, right? So Rust, C, Go, Python, and JavaScript might all represent those types, like the string and error types, entirely differently. And so trying to get them to interact with each other across different languages just cannot work in the current environment. Right. 1 second. Okay. So one of the primary goals of the WebAssembly component model then is to create a way to wrap a WebAssembly module and say, this function taking a number and returning a number is actually taking a string and returning an error, or taking an error and returning a string, or taking a string and returning a number, like whatever, right? And to then provide a way for us to connect programs together more effectively, right? So, so that's what I was just saying. Those are the things I said, thank you. So yeah, it ends up looking like this, where the idea here is that these two components could be written in two different languages, right? And so I'm saying here that like I have a string and an error coming out as one export from one, and I have two numbers coming in on the other one. But like because of the way the compiler works, we can actually like transliterate those types between each other. So, okay, who cares, right? That was some fairly dense, kind of esoteric information that is not actually relevant to most of your lives. Why am I talking to you about this? Well, I'd kind of like to take a step back because it seems to me that the majority of talks at like these kinds of conferences are frequently from providers to developers or from developers to developers, right? Platforms to developers, developers to developers. And for the purposes of this talk, I actually want to talk to both sides of that group. I want to talk to the platform developers as well as the people who are building their applications on top of them. And this is going to make sense, I swear. I hope. Okay. So let's call them Alice and Bob. Alice is a platform developer, provider, and Bob is a application developer who builds things on those platforms, right? Now, what do Alice and Bob care about when it comes to a serverless platform? I think that there are probably a lot of things, but I think we can kind of break it down into three separate groups, right? One, and like I don't think anyone would disagree with this, is security. They both care about security, right? Whether or not they mean the same things by security is a different question, but they both care about it to some extent. I would argue that they care about languages and runtimes, but they actually have like kind of different preferences about this. Alice, as a platform developer, really doesn't want to have to support a ton of different languages, not to mention a ton of different versions of a ton of different languages. Every one of those ends up requiring a group of developers to maintain them and keep them going and fix security bugs and all sorts of other things, right? Whereas Bob really wants there to be a maximum number of languages because he wants his team to be able to just choose whatever language works best for their problem, and then off they go and they're running, right? So they kind of have like totally different perspectives on this. I'd argue the same thing applies when it comes to like functionality, like things that are available on the platform itself, right? Alice wants to minimize the number of APIs, both for like security purposes, but also because like, again, more APIs is more crap to maintain. Whereas again, Bob is trying to maximize functionality to minimize the amount of work for his team. Okay, so security, right? Again, from Alice's perspective, when we talk about security, what Alice really cares about, I argue, is not protecting the developer or the application, but rather is actually much more about protecting their platform, right? When Alice talks about security, Alice is like really talking about like, hey, I want to prevent you, the developer, from being able to break into my internal systems or cross boundaries that you're not supposed to be able to cross, right? Whereas when Bob is talking about this, Bob is actually looking at like, hey, how do I protect myself from malicious end users, or even potentially from my own internal developers, or from other developers on your platform, right? And so these things kind of overlap with each other, but they're not really the same thing, right? And so when Alice chooses certain technologies here, let's say, I don't know, virtual machines, right? Like traditional virtual machines, right? That is a great example of something that Alice can use to protect the platform, but does not actually protect the developer or the application particularly well. Okay. Need to remember to breathe when I'm on stage. It's been a little while. Okay, right. Runtimes and languages. This is a similar kind of story, right? Where like Alice, it's not that Alice doesn't care, right? Alice does want their developers to be able to use the things that are best for them. But they also want to like minimize the number of those languages that they need to maintain over time, right? Alice does not want to have to maintain Python 2.7 like runtimes on top of their platform, right? They want to be able to like continuously move forward, right? Whereas what Bob cares about is like, the code that I currently have that I am trying to deploy, what language is that? I don't want to have to like think about like switching it over to like some new version of this. I want to be able to just like deploy it and off I go, right? That's the thing that Bob used to be able to do when they weren't working in a serverless world. But now that they're moving into a serverless world, they now have to think about what languages does my provider support, not just what languages do I want to support, right? And then finally, again, we have APIs and functionality. So again, Alice, for all the right reasons, is like, hey, I want to minimize the number of like APIs that I have available on my platform, because the more APIs I have, the more security vulnerabilities I have, the more teams I need to maintain those particular things, and so on, right? Whereas again, Bob is just trying to get his job done. Okay, so left turn. Who here is familiar with WASI, WebAssembly System Interface? Couple, a little bit, right on, great. Wow, man, we really have a lot of work to do in the ecosystem. Okay, so WASI is a proposed set of interfaces that are available inside of WebAssembly, and specifically as things that components can connect to. It's supposed to be a standardized way of being able to say things like, as an example here, what do I have here? There we go. For instance, a standard way of saying like, all right, on one platform I have HTTP, and on the next platform I have HTTP. Those two HTTPs should be the same thing if we're both using WebAssembly, right? I should be able to take a program that only uses HTTP as an interface, and I should be able to move it from one platform to another without anything breaking, right? That is the idea behind the WebAssembly system interface. It started out as basically like POSIX for WebAssembly, but the more that we like thought about it, the more we realized that like that's not actually sufficient. We need to be able to break things down into like more granular and also higher level concepts. So the reason for this is about virtualization. So This is where I think a lot of this stuff will get tied together. When we talk about virtualization, I think a lot of us think about things like virtualization primitives and CPUs, or like, hey, I use like a virtual machine or whatever. Virtualization has a much more, I don't know, vague meaning than that, right? Right, it basically means being able to say like, hey, I have a thing that I want to use here, and I don't necessarily want to use the real version of it. I want to use a version of it that like has been abstracted out, essentially. So like, let me give you an example of this. So let's say you are on a particular platform that is using WebAssembly and the WebAssembly component model and WASI, let's say. And you only have on your platform the HTTP interface and the random interface available. Those are the only two things that are available, right? Your code, however, needs a file system. How are you going to get a file system, right? Well, because of the way components can connect to each other, and because there is a standard definition of what a file system is, I can just write a component that acts exactly like a file system. And we're going to pretend for a moment that the only function you need for a file system is read file, because this is a much simpler way to write slides. So in this case, like, it's not a terribly useful file system, right? This is just a file system where if I try to read a file, I return an error, right? And you go, okay, well, my code actually needs, well, one of the weird things that my code needs is I actually need to be able to read the dev random file, right? Because some weird library I'm using, that's how it interacts with like the randomness like function. Well, I have a random API, but it doesn't match that on the file system. So what can I do? Well, I can very trivially just make a little component that exposes if the path is dev random, I get some random bytes out of the random API, and otherwise it passes it along. Likewise, if I need my configuration to be available, well, there is no file system, but there is an HTTP interface, so I could just call out and ask S3, like a particular bucket on S3, and like have that pretend to be a file system. And for all intents and purposes, from your code's perspective, it is a file system because it matches the exact interface it's looking for. So that's what we're trying to do here. Like, for like a slightly different example, like, and this is, I think, where it gets interesting for both providers and practitioners. The idea here is that it's not just helping the providers or the practitioners, it's actually helping both, because let's say the provider only really wants to expose an HTTP interface. That's the only way out of their platform, right? We're minimizing the number of APIs as much as we possibly can. Well, again, as a platform, I could provide a file system. It just can be a component that you can import into your code, right? Which just uses HTTP to go make a file system. Likewise, I could do a KV store that way. Likewise, I could do a pub subsystem that way. And your code, at the same time, might be like, all right, those are all useful, but what I really need for my code is configuration. Well, okay, again, just pull that directly in from the file system. Or, for instance, maybe I am like developing some sort of observability libraries, right? Well, I could pull in both the KV store and the pub subsystem, and ultimately, this is all eventually going through HTTP to get out of that platform. But like, the APIs that are available can be entirely fluid because of the way that like components work, right? And so when we come back to this, I would like to make the argument that WebAssembly actually like makes these things suddenly not against each other, right? The platform developer gets their security because of the security from WebAssembly. The developer gets their security because of the granular isolation that comes along with it. Likewise, the platform gets what they are looking for with fewer languages because they only support WebAssembly. They don't have to think about individual languages, whereas the developer gets to use any language that compiles to WebAssembly. So, all of this said, my like general thesis for this talk is that with WebAssembly, the tools that you use to build your applications are the same as the tools used to build the platform. And that is kind of the first time that that has happened, right? Like typically, the people who are developing the platform, the people who are developing the applications are working with an entirely different set of technologies. Here, we can actually use the same thing and end up getting the same benefits on both sides of it. So, lastly, I just want to say, like, I think that Fastly's goal since the very beginning has been to make a platform that feels like it is part of your infrastructure, that feels like it is part of your application and what you already have. It feels like it's yours, essentially, right? WebAssembly gives us a really powerful way to do that, right? And that is why, when I was CTO, I made the choice to use and make a bet on WebAssembly for this, because it's so closely matched up with the values that we care about. It lets you make the platform what you need it to be for your specific application. So that's about it. Let's say thank you.
Thank you, Tyler. Very good.
Cool.
Excellent. Thank you, sir.